dilution of acid and bases with water. Okay. Now acids and base are mostly soluble and can be diluted by adding the required amount of water. In laboratory, when you go to higher classes, when you go for experiments, you will observe it. There are dilute acids and the strong acids. So dilute acids means the more quantity of water is added in that acid, and the stronger acid also not given in the pure form to you, that is also little diluted, because the acids and bases are highly corrosive in nature. So there should not be any accident for the younger classes of students, because they don't know to handle the chemicals. That is why when research purposes, when it is used, the exact quantity or exact concentration is taken. That time, if required, only a required quantity of dilution is done with the water, or otherwise it is pure form is taken. Now acids and bases are mostly water soluble and can be diluted by adding the required amount of water. In fact, with the addition of water, the amount of acid or base per unit volume decreases. Per unit volume decreases. It means what is happening? The quantity of water is increased, so number of ions are decreasing and dilution occurs. That is why it is called dilute solution, because number of ions like HCl breaks to H plus and Cl minus. Now we added more of water in that. Okay, so what is happening? That H plus and Cl minus quantity ions is much lesser than the water molecules. That is why it is called dilution. Okay, the process is generally exothermic in nature. Exothermic means any time when the reaction, two reactants combine and a lot of heat is generated, the flask or the conical flask or the beaker where we are making a solution, it is warm to touch. It means the lot of heat is generated. That kind of reaction, product side, when it is generated, is called exothermic. Exo word is outside and thermic is heat. So heat is liberated outside or evolved outside is called exothermic. In some cases, so much heat is evolved that the acid or base immediately changes into vapor state. Okay, this will lead to the formation of dense fog, which is likely to pollute the atmosphere. Okay, so now what are the cautions we should follow? An acid should be diluted by adding acid to water. We have already discussed this. Once again we will talk about this, adding acid to water. Why we should add acid to water, not water to acid? Because acid will spurt out. It might spurt out on your skin, your clothes, whoever is preparing solution. So it may cause accident. That is why it should be always adding acid to water and not water to the acid. If water is added to the acid, the heat produced, because it is an exothermic reaction, may cause the mixture to splash out. Okay, and causes burns. That is why acid to water is added. The glass containers may also break due to excessive heating. Okay, so generally acid solutions also will be made or taken into glass beakers or glass containers. Why? Because glass does not react with acids. So that is why most of the apparatus in the lab you will see, which is where we are using acids or bases, will be made up of glass. Why? Because glass will be non-reactive with them, and that is why it can be used. But sometimes when we are having this kind of reaction, we are preparing a solution. So if we are adding water to the acid, what will happen? Lots of heat is generated. It may break a glass apparatus also. So that is why always add acid to water, because of it is a highly exothermic reaction. Large amount of heat is generated and the acid may spurt out and it may cause accident. That is why acid to water should be added. Okay, clear? Now see here, they had shown you one diluting concentrated sulfuric acid with water. So water is added to acid, acid is added to water. They had shown you. Now this is the correct way. This is the correct way when acid should be added to water. Now water is added to acid. What will happen? The heat generated is uncontrollable and acid may splash out or it may break the glass apparatus. That is why acid to water should be added, not water to acid. Okay, clear? Then whenever a concentrated acid like sulfuric acid or nitric acid, what is the formula? We can simultaneously work on that also. H2SO4 is sulfuric acid, HNO3 is nitric acid, Okay, what is hydrochloric acid? HCl is the hydrochloric acid to be diluted with water, and must taken that acid should be added dropwise to water, taken in a container with constant stirring. Okay, heat evolved in this case will be quite slow, because we are constantly stirring, uniformly heat is distributed, and dropwise we are adding. If we add in one shot, lot of heat is generated, and that may be the cause of accident. Okay, if water is added to the acid, it will have affinity for the entire quantity of acid present. So much heat will be evolved that the glass container in which dilution is carried will crack. Moreover, the vapors released in the atmosphere will fog and cause a pollution problem. That is why what we should do, is it clear now? We should remember this very well, because whenever in future you are doing experiments in the lab, you should never forget this, otherwise you may have to face with lot of consequences of this, and any dangerous accident may happen. So always add acid to water. Okay. Now let's see, acids and bases may either will be strong or weak according to Arrhenius theory. More the number of H plus ions released by acid in water, stronger is the acid. Similarly, more the number of OH minus ions released by base in water, stronger is the base. Okay, Arrhenius is given the theory. According to his theory, the substances, how they are identifying substances which breaks and gives H plus ions, okay, are called Arrhenius acids. Okay, and substances which breaks and gives OH minus ions are Arrhenius bases. Okay, now here how it is identified, more the number of OH minus ions by a base in water, stronger is the base. Okay, so acids and bases are as either they can be strong acid, strong base, or weak acid, weak base. Okay, so we can say strong acids. We can write it here. Few acids are considered as strong acids, like hydrochloric acid, sulfuric acid, nitric acid. These all acids are called here strong acids. Now what are the weak acids? Weak acids are our acetic acid, CH3COOH is acetic acid, is a weak acid. Okay, similarly strong base, if we list out strong bases, NaOH, sodium hydroxide, potassium hydroxide. Okay, these are the strong bases. And if we say weak base, ammonium hydroxide, NH4OH is a weak base. Okay, now let's see what are the acids and bases properties in a flow chart. We can quickly understand. Okay, so first we will talk about acid. Yields an excess of hydrogen ion in aqueous solution whenever like HCl breaks to H plus and Cl minus. Are you getting? This is it mean. Next is have SAR2 test, like lemon or tamarind will have different kind of acidic substance present, that is why they are SAR2 test. Or acid like acetic acid, or we have sulfuric acid, we cannot test that acids, but we have few diluted acids which we are using at the daily life, that is lemon is there, tamarind is there. Okay, then turn blue litmus red. Blue litmus turn red means substance is acidic by nature. Okay, this is the identification of acidic substance. Then acid can be classified as strong acid or weak acid. One example we will write, like hydrochloric acid is a strong acid, so acetic acid CH3COOH is a weak acid. Okay, this is strong acid, this is weak acid. Getting it? There are two types of acid, organic acid and mineral acid. Mineral acid, which is the source is minerals, or rocks. Organic acid, which is from the any organic body, it is obtained, that is called organic acids or mineral acids, correct. Then acids can be divided according to how many hydrogen it is giving on ionization. If one hydrogen it is giving, it is called monobasic, okay, that is called basicity. Replaceable hydrogen is called basicity. So substance is called monobasic, dibasic, tribasic. We can write it here. Some example like HCl breaks to 1H plus, okay, H2SO4 breaks to 2H plus, okay, and this is example of monobasic, this is example of dibasic. If we have to talk about tribasic, then phosphoric acid is there, H3PO4 is breaking as 3H plus and PO4 3 minus, okay. So these are monobasic, dibasic, tribasic. How it is decided, the basicity? What is basicity? Basicity is number of replaceable hydrogen atoms. Number of replaceable hydrogen atoms is called basicity, okay. Clear it is? Then when acid reacts with active metals, okay, to form dihydrogen, like for example active metals means if we talk about sodium, so we are getting dihydrogen, hydrogen gas is liberated, okay, reacts to neutralize with neutralize each other to form salts. They are like with bases also, acid and base reacts, you are getting salt, like NaOH plus HCl, you are getting NaCl, salt plus water, so you are getting salt, okay. Now acid completely we have covered. Now base we will discuss. Then excess of hydroxide ion in aqueous solution, same way we are talking. One base we will take, when it breaks, NaOH will break as Na plus and OH minus, okay. Then it has bitter to taste, okay. So it is bitter means like bitter gourd kind of taste, or we can say washing soda. Then turns red litmus blue. What does it indicate? Substance turns red litmus blue means substance is basic by nature, okay. Then all alkalis are basic in nature, but all substances are basic substances are not alkalis. That is also because their solutions are alkaline, okay. When pH test is done, solutions are alkaline, so all alkalis are bases, okay. So we can say solutions are basic. Then with reacts with metals, like base reacts with zinc, we have seen the reaction. We have NaOH plus zinc, we are getting Na2ZnO2, sodium zincate is obtained, okay. Reaction with base and hydrogen gas is liberated here also. Clear? So this is the properties of flow chart, acids and bases.